Scientists are not actually more intelligent in a biological or magical sense compared to other humans. What makes them appear more intelligent is a combination of trained thinking habits, specialized knowledge, and a systematic way of solving problems that most people are never taught to use deeply. Human intelligence is broadly the same across populations, but scientists develop a different cognitive style through education and practice that focuses on analysis, evidence, and structured reasoning instead of intuition or assumption.
The main difference starts with how scientists approach problems. Most people see a situation and try to answer it quickly, based on experience, memory, or common sense. Scientists slow this process down and break problems into smaller parts. Instead of asking, what is the answer? They ask, what are the conditions? What causes this? And what evidence supports this idea? This shift from answer-based thinking to question-based thinking is one of the biggest reasons they achieve deeper understanding.
Another key reason is curiosity intensity. Many people experience curiosity occasionally, but scientists train themselves to sustain curiosity for long periods. They do not stop at surface explanations. If something behaves in a certain way, they continue asking what is behind it, what mechanism drives it, and whether the explanation is always true or only true under specific conditions. This continuous questioning leads to deeper layers of understanding that are not visible at first glance.
Scientific thinking is also built on structured logic, rather than belief or assumption. In everyday thinking, humans often accept ideas because they are familiar, socially accepted, or emotionally satisfying. Scientists are trained to distrust assumptions and rely only on what can be measured, tested, or repeatedly observed. This reduces errors caused by bias, emotion, or misinformation. It also forces conclusions to be supported by evidence instead of opinion.
A major factor is the use of the scientific method, which organizes thinking into a step-by-step system. This system includes observing a phenomenon, forming a possible explanation, predicting what should happen if that explanation is correct, testing it through controlled experiments, and then analyzing results. This process removes randomness from thinking. Instead of guessing, scientists follow a repeatable path that gradually filters out wrong ideas and strengthens correct. Observation skills are another important difference. Scientists are trained to notice small patterns, changes, and anomalies that most people ignore. In many discoveries, the breakthrough did not come from a big idea, but from noticing a small inconsistency in data or behavior. This attention to detail allows scientists to detect hidden rules in nature that are not obvious at first sight.
Error handling is also fundamentally different. Most people treat failure as a negative result, but scientists treat it as information. When an experiment fails, it is not considered wasted effort. Instead, it is analyzed to understand why it failed and what it reveals about the system being studied. Each failure eliminates incorrect possibilities and narrows down the path toward a correct explanation. This turns mistakes into a core part of progress, rather than something to avoid.
Another important factor is long-term thinking. Scientific discoveries are rarely immediate. They often require years of repeated testing, refinement, and verification. Scientists develop patience and persistence because they understand that complex truths cannot be discovered quickly. This allows them to continue working on problems even when progress is slow or uncertain, while many people give up early due to lack of immediate results. Education and specialization also play a role. Scientists spend years focusing deeply on specific domains, such as physics, chemistry, biology, or mathematics. This deep focus builds strong mental models of how systems behave. Instead of having shallow knowledge across many topics, they develop deep understanding in fewer areas, which allows them to make accurate predictions and design complex experiments. Overall, scientists appear more intelligent because they combine curiosity, disciplined thinking, structured methods, patience, and evidence-based reasoning into a consistent system. It is not that they are fundamentally different humans, but that they train their minds to operate in a way that reduces mistakes, increases accuracy, and continuously builds knowledge through testing and correction.